Hi, this video we continue with the regression analysis, and this in chapter 23 we basically discussion all the concepts based on this example. We have a data file about the facts, and first we derive the linear expression, the linear equation, and then we do the linearity assumptions, check all the assumptions. Basically, in this case, we will talk about the residue analysis. And last topic, we will talk about the confidence interval or prediction interval for this example. So let's take a look on the Excel. In the Excel, that's the data files, that data sets in this example contains 3 categories, but the only 2 we want to talk about in this example is the percentage body fats versus the waist size. This is only contains like 20 samples. And we did, so same thing, we select X value, Y value, and then do the scatter plots. And then remember to show the trend line with the equations and R squares. So that's basically we have the equations of the linear regression equation and R squares value. And the second method we did, remember this one, we use the data analyze tools. So regression, so in these tools, we just select the Y value is the percentage body fats, and the X value is this waist size. And then remember, we check the labels, confidence in levels, and output in a new worksheets, residue plots. So I'll check all those to give us the outputs. I already generated this expression, these results. Take a look at this one. So basically, so you can see we get the results from the regression analysis. We have the R square, and the standard error IC, and sample size 20, and intercept coefficients, standard error, the waist, which is the slope coefficients, standard error. So these 2 values is basically we'll plug into this expression. And also, by that regression analysis tool will provide 3 figures. So 3 figures. So first, as we talk about, we want to analyze these residue plots. So the residue plots, we want this one, since this dataset only have 20 data, so you can see they are reasonably surrounded by the central line. That's basically 0 residue, that perfect fit linear predicted value. So we check the equal variance. That means the data on the positive and negative portion, they have the same similar the variance, and another is the no patterns, no obvious patterns on this data. So this all exam is tell us this data is random chosen, and there's no pattern, so that's no outlier. So that's this figure tells us. And next figure, I want to check the conditions is the normal probability plots. And look at this one is, you can see this is quite well fit with this diagonal line. So that's the probability line. And this one, if it's a perfect fit, then we see it's fit the normal condition. And this one is very close to fit the normal condition. And the same as before, we talk about another two figure we can check the normality is the box plots and the histogram. Remember before we talk about because we only have 20 data sets, the histogram may not be very useful because the very small data sets, they may not show any pattern. So this one does not really useful for this question. But on the other side, you look at the box plots, it's almost a perfect box plots. The whiskers is almost the same length, even though the median is not perfect in the middle, but very close. And no outliers are in this one. So we see in this case, the data is fit linear normal condition, meet linear normal condition requirements. Let's come back to the notes. So that's basically the same figure, similar figure with the Excel outputs. They just a little waste and residue, but this one is a fitted value with residue. We don't have this one in Excel. And this one is quite similar to our normal probability plots. So there is a little bit different. We see this one, normal probability plots. You probably notice I didn't really distinguish X value and Y value sometimes because for a perfect normal distributed data, it is a diagonal line. So that's normally say the X value, Y value does not really matter. That means our residue should be in the x-axis, percentage on the y-axis. However, in our normal probability plots by Excel, you can see the sample percentile is on the x-axis and the body fat is on the y-axis, but doesn't really matter here. So we continue look at the notes. So we read those notes. And this is also explain R square. So R square, that's 78.7% of data can be explained by this model. It's a pretty good linear model. And we look at this is the standard error of the slope. We want to see the beta 1 or B1. That's the slope. And we did confidence interval analyze on slope. So this one is normally we ask you in the assignment is the hand calculation of this confidence interval. So you need to know how to do the calculation of this confidence interval, and T alpha over 2. So that's basically give us the value from that table, or you can use in Excel. We have the function to get this value, and 0.273 in our Excel outputs. So that's basically the standard error of the beta 1. So that's the slope. So slope coefficient is this one. The slope standard error is this one. So 0.27278. So close to 0.27273. So that's why we use this value here. Do the calculation of this one. And one more last topic we want to talk is 95% confidence interval for a given X value. So this one, because Excel does not really provide this calculation rather than other statistic softwares. So in this case, I did design the templates. So let's take a look at the templates. So this templates is called regression confidence interval and prediction interval analyze templates. So these templates will require several values you need to fill in these points. So let's just put both Excel files over here. This is our regression report, analysis reports, and this is the templates. We need to fill a few numbers here. So first, let's take a look. This is the sample size. Is the from your report is observation. So the observation is 20, and then standard error is just this standard error. That's called the residue standard error. And then we have intercept coefficients. And this value is the intercept coefficient, this value. So you can see this one filled in. And then intercept standard error is this value. And the slope coefficient is basically this value. And slope standard error is this value. So that's basically these values. And to do the prediction, we also need the mean value of sample data X and the mean value of the data Y. So how we get this one is basically from our data sets. So that's a simple way. So instead of we doing all the calculations, simple way we just get the average of this value, the percentage body fat, and the average of this waist size, and then fill in these two values. And the prediction values in this case, sometimes it will ask to predict a sample mean value. If we have another sample, say 20 other values, so we can predict the mean value, or for a given X value. So that's so this in the example later on we'll see in the notes. This one is using 38 for the waist size. 38 we want to see its predicted value and its confidence interval. So get this one, come back. So we fill this 38 with alpha level 0.05, and we have so once we fill these values, and the predicted value are coming out, it's 21.8597, and these two values are not usually asked to calculate, but it's used to do the confidence interval calculation. So I just put these two values here, but remember this is the value probably you need. And then we have a mean prediction confidence interval. So that's basically we will say for the mean of another 20 samples, we see if its average value is 38, then we see it's 95% confidence of that value. 38 is between this 19.658 24.060, and this is say this average 38 of that subset contains the true population mean. So 19.75 is in between these two values. And another value is if this 38 is a individual person's waist size, and then using that one, we want to do the individual prediction. Because only sample is only one, we can treat as that one person as one sample. So individual prediction will be wider range. So you can see we did this calculation is this value, and you check the results with the notes. That's the correct results. So you see the notes, the value is fit with our results, and also from the Minitab is also give us the same results. That's all. Thank you.